Why are you sitting in your chair today? Does gravity pull you to the floor? No, there is no such thing as gravitational pull. We lied to you.
First of all, we are born scientists. When we're born, we wonder what's out there. We begin to wonder about the sun, life, the stars, what makes the oceans, the weather. We're born scientists. And then something happens. When we hit the danger years of junior high school and high school, that's when it's literally crushed out of us.
Those are the worst.
Every little flower of curiosity, said Einstein, is crushed by society itself. Because we have to learn all these facts, figures, memorization, we think that memorization is science. And that's not true at all. In science, we always say that you make observations, you have a theory, you go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
No, I'm not. What's happening?
All right, you guys want to give this a shot real quick?
Yes, I want to give this a shot.
Okay, this is going to be my last one for sure. All right.
Okay.
So, two very easy questions, multiple choice. So, first one, I have 3 box trucks. They're all completely sealed, they're all on a level surface, and they all have an apple hanging from a string.
Okay.
The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
B.
Yes, why would you say B?
Because when the car moves forward, the ball or the apple would hypothetically move backwards because the apple wants to stay where it is because it's isolated and the movement is happening around it.
Okay. Yeah. I like that answer.
Thank you.
Yeah. So yeah, it's because it's not moving.
Yeah.
That's why this one's at rest. So which
Right.
one's accelerating forward?
The A.
A, right? And that's because the whole surrounding is moving, but this is maintaining its position.
Yes.
So due to inertia.
Yes.
Yeah, you got it. Perfect. That's the first one. It's pretty elementary though. So again, same thing, pretty similar. The only difference here is that instead of an apple, it's a helium balloon. But out of these 3, which one is at rest?
B.
Yes, and it's for the same reason as the first, because there's no motion. Which one's accelerating forward?
Still A.
A. That's your final answer?
Yeah.
No, it's actually C.
What?
So there's 2 reasons why it's C. So the first reason is air is more dense than helium. That's the first reason, right?
Okay.
The second reason is a force. So as soon as I apply a force in this direction, all of the air that's inside of the box truck is also being forced in that same direction through space.
Oh,
and because
I see.
air is more dense than helium, is able to push it along with it.
Okay.
Yeah, you can't do that with the apple because the apple is more dense
more dense than
air,
air,
so the air
yeah.
can't push it. So
I
it just
see.
gets left behind.
Okay.
Yeah, and I can show that here. Like this is a buoyant object, which is less dense in the water.
Okay.
So if I apply a force in this direction, what direction will the ball go?
Wait, so
This is a
the ball
buoyant
more
object.
dense than
Yeah, the ball is less dense.
Oh, it's less dense, then it's going to go forward.
It's gonna go forward. Yes. Yeah.
Yeah,
Forward,
okay.
yes. It's physics. It's reality. Yeah. So here, this is the "Are you smarter than a 5th grader?" question now. So, based on the principles that we just learned, I have a helium balloon and an apple hanging from a string inside this cargo balloon. What direction would you say I accelerated? To the right or to the left?
Wait. Wait, let me check.
Yeah. Which one? Okay, let him answer.
It's going this way because the balloon is going this way.
Yes.
Yeah.
Yes. That means the air is being forced in that direction, which that's how the helium balloon is able to get pushed. Obviously, the apple has apparent motion because it just got left behind. The helium balloon has true motion because it's being pushed.
Yeah.
Yeah. So one last question before you guys go. If I have a helium balloon here on Earth and I release it, what direction does it go?
Like
If I have a helium balloon,
in proportion to me or
yeah, proportion to us,
Okay.
relative to us.
It goes up.
It goes up. Yes. Why does it go up? You think?
Because it's less dense than air.
Yes.
And so then it's going to float on top of the air, like buoyancy principles, but yeah. I should not like
So yeah, that is the first reason why helium balloon rises, because it's less dense than air, but the second reason is a force. You need a force still. So again, so the air is pushing up the helium balloon. In this scenario, the truck pushed the air, which then pushed the helium. What's pushing up the air here on Earth to be able to push up a helium balloon?
normal force.
Yes, it is the normal force of the Earth. You got it. So yeah, so here's the reality. gravity as a pulling force has never been measured or detected, and that's why it's just a theory.
Yeah.
So the reality, the only force that exists here on Earth is the normal force, which is an upwards push of the Earth.
Yeah.
What does that mean? Well, that means that when you release an object into free fall, everybody believes that this accelerates down to the Earth. But the reality is the Earth moves up to the object in free fall. So this only falls back due to inertia. So there is no force accelerating down to the Earth. The only force is the air being pushed up, which is pushing up the helium. And what's pushing up the air? It's the Earth.
Okay.
So the Earth is pushing up against you right now. It's not pulling you down towards it. So that's the reality. So what does that mean, right?
What means that the fifth graders don't know all this, actually.
No. The basic principles of buoyancy, that's a fifth grade question. Now we're getting into more complex. So you guys believe the Earth is a ball, right?
Yeah.
You guys understand that on a ball, up is relative. Right? So if you're standing here, up is this way, but if you're standing down here, up is this way. But if you're standing here, up is this way.
Yeah.
In every direction away from the center is up on the ball. If we could prove physically that the Earth is not pulling you down, but in fact is pushing up, in other words, it's moving up through space, how can the Earth move up in every direction at the same time if it was a ball?
Wait, are you arguing that the Earth is flat?
Not flat, level. There's a huge difference. Level point. It's a level point. So,
Well, I think... Wait, sorry, ask a question again.
So if we could prove physically that the Earth is pushing up against you and not pulling you down, because that's what physics shows, that's what buoyancy shows, and the fact that there is no proof of gravity is just a theory, how can the Earth move up in every direction at the same time if it was a ball? Well, rotating just means moving this way. It's not moving this way.
Well,
this
I don't
way,
think
this
the
way.
Earth is moving up in every direction.
Yeah, I know you don't, because you believe in a pulling force of gravity.
Yeah.
But if we could prove that it was, in fact, a pushing force, how would that work from a globe? It's a kind of a hypothetical question.
I don't think that it would work.
I know it won't work, because that would mean the Earth will have to be expanding.
Yeah.
And it would just explode.
Yeah,
it wouldn't work. So the fact is, in order for people to believe in the ball Earth theory, you have to believe in the theory of gravity being a pulling force. Because if we could prove that it's the other way around, then the whole heliocentric model falls apart.
Okay.
Because that's the Achilles heel to the globe. They require a pulling force of gravity in order to sell a globe Earth concept.
Okay.
So that will be the number one proof to debunk the globe Earth, is the fact that the force of the Earth is a push, not a pull.
Okay.
Buoyancy shows us that.
Okay.
So if I was to ask you guys respectfully, why do you guys believe the Earth is false?
Like satellite imagery, number one.
Images.
Number two, I was taking this astro class, and they're like, damn, like flat earthers don't really know things, and they made us like disprove a lot of stuff for that. Also, because with the same logic, if we have the idea that gravity like is just a theory, and that the normal force is like having Earth pull things towards us, if I'm like hanging by my neck from a noose, I'm not like getting caught up by the ground. The ground isn't coming up to catch me, and it's not because the like noose is more or less dense. It's just because it's there, so I can feel the weight on my neck, and so I'm gonna die. You know what I mean? Like that's
Like you're talking about, like if you hang something from like a string.
Yeah.
Well, right now this doesn't fall because I'm connected to the Earth and I'm holding it up.
Right.
Yeah, but if I disconnect, then the Earth does come up to it. Same thing with your
the
neck.
Earth doesn't
if
really-
you disconnect, then the Earth will come up to you.
Yeah. I mean, true.
You're connected to the
However,
Earth, that's why.
the force that I feel is still real.
Yeah, it's an upwards push. The reason why you feel your weight is because you're experiencing an upwards push, and your body has inertia. It wants to remain in its position in space, so that's why you have weight, because you have inertia, and you're resisting the upwards push. So the globe Earth flipped the script. They're claiming inertia is the force, and then the Earth is just resisting. But it's the other way around. The Earth is the upwards force, and inertia is just resisting.
Okay.
So they just flipped the script.
But if the normal force does exist,
Yes.
then we would not be. I feel like we wouldn't be standing on Earth. We would all just be like pushed out into infinity. When does the Earth know when to stop?
Well, that's the thing. The reason why if you jump, you come back down, is because you're not necessarily coming back down. It's just the Earth catches up to you again. So because again, your body has inertia. So when you jump, you're applying extra force. So that's why you gain distance from the Earth. But you'll instantly start to lose that momentum. So the Earth catches up again. Does that make sense? So you jump, and the Earth just simply catches up again, because your force obviously wasn't strong enough to keep you going up forever.
No,
'Cause
but
you have
I mean
inertia.
more in the sense that like when they were teaching us basic physics in like 6th grade, or was that 7th grade? In like 7th grade when they were teaching us physics, the normal force was created in theory to the force of gravity, because there was nothing. Gravity would have said that like, oh, we just like, if we had landed, we would just like keep going down because of how like inertia works. So there has to be something that stops us from doing that.
Yeah.
So if there wasn't gravity, then we would just like, float off, and Earth would just like be like moving out in a bunch of different ways, as you suppose.
Well, I would say if there wasn't any inertial resistance to force, then we would do that. But I would say your mass has inertia. All mass has inertia here on Earth. So the more mass you have, the more resistance you're going to have because the more mass you have.
Right, but mass is defined by gravity.
No, well, mass is affected by gravity. It's not defined by gravity. So based on how much mass you have, and you're gonna have
I'm gonna weigh
so much
less in space, no?
Well, outer space, anything about outer space is just concept. So now we're talking theoretical physics.
Well, they measured people in space. They measured people in space before.
Were you talking about like in the space station, for example? Or
Yeah.
I would say that a lot of these videos that were being shown from ISS, they're done. Have you heard of zero-G flights? Yeah, parabolic maneuvers. So a lot of they give you the free falling effect of floating inside of an aircraft. And a lot of these experiments that they do, they just simply do that.
Okay.
They're doing parabolic flights, and they're not really going into outer space. That's my opinion.
Okay, cool.
Yeah, so that's the reality. Nobody's been to outer space, in my opinion. It's all just a concept to reinforce the globe Earth model.
Okay.
Yeah, because
So you believe the Earth?
I don't believe the Earth is flat. I know the Earth is a level plane that's pushing out.
Okay.
That's a fact. I don't know the exact dimensions of the Earth. I don't know how far it extends. I don't know what's containing the Earth physically, but that's what it shows me.
Okay.
And I don't have a bias. I just go with what reality shows me.
Okay, cool. Well, thank you for your time.
All right, no worries, man. I appreciate the chat, and you guys take care, man.